for Anas as well. I know Anas is facing some issues. He has discussed with me. Anas, please stay back after today's session. I'll discuss things with you. Everyone, you may lower your hands now. So till now, what we have discussed is we have discussed what is Android pen testing, what is Android bug hunting, difference between both of them, which approach is better for us, what are the common security issues, what are the common problems that we get to see with Android apps. Then we saw what is an attack surface, Android attack surface, client-side vulnerabilities, server-side vulnerabilities, logical security issues. What are they? What do we mean by them? Then we saw setting up the lab. We installed Mobaxler. We installed Genymotion. In Genymotion, we installed OpenG apps, that is G Suite. We also installed ARM Translate. Along with this, I must have also shared a YouTube video link with you that contained the complete setup of how can you set up your own Android lab. And after that, we have to discuss about the Android, because as a security researcher, as a pen tester, it is important for us to understand that if we are trying to break anything, if we are trying to hack anything, we need to understand it's working. For that reason, if we are trying to look out for security issues or bugs in Android applications, you need to first of all understand how is Android working, what is the architecture of Android. Then you need to learn how is the Android application working, how is Android assigning permissions to the Android apps, how is the overall process happening when you run any of the app, when you unlock your phone and you click on Google Chrome, what is the backend process that happens when you click on reset and you simply remove any of the app, you kill that app, you kill that process. So what does that mean? You must have seen that when in your Android phone the battery is low, how does the mobile get to know? How does the Android get to know that these are all of the processes that can be killed? Because the battery is no, now we are in the power saving mode, so we do not have to check for emails. Now, because we have less than 15% battery, we do not have to check for WhatsApp messages. We do not have to turn on the flashlight. How do all of these things happen? You will be able to understand these things better when you will be having a look at the Android architecture. This is Android architecture. You can find this image online when you go to developer.android.com. You can simply do a Google search Android architecture or Android OS architecture, and this is the application. This is the architecture that you will come across. This is from bottom to top. The more you go up, more you will be away from the hardware. Like, let's say here, down here in my taskbar, here we have the the hardware. We have the camera, we have the microphone, we have the sensors, the proximity sensor, we have got the charging pin, the buttons, all of them are here right above the hardware. This is the Linux kernel. Android is an operating system that is based over Linux. It is a Linux based open source of operating system that has been developed by Google. All of us know that Android is an open source project. Till date, Android is open source. So here, this is managed by Google. This is a Linux based Android. This is a Linux based operating system. This was majorly used. This was devised for mobiles. We say that we have a mobile, so the mobile phones are considered generally that these are mobiles, but originally this is what we meant by mobile. We have mobile means something that can move. One is mobile and one is stationary. Mobile means something that can be moved. For example, the phone that you have, it goes along with you, it moves along with you, you can take it anywhere. Unlike the landline that we have, landline cannot go everywhere, it is fixed by a line. Whenever you have to call someone or answer a call, you have to go to that room, pick up the receiver and then answer. So that landline is stationary. The phone that you have is mobile. Android was made for mobile devices. Please pay attention to the terms here. I'm not saying mobile phones. I'm saying mobile devices. Those devices that can move. Those things, those gadgets that can move. For example, you have a car. In car, you have the smart infotainment system that is mobile, that can move, that is using Android. For all of those devices that are small, that are handheld, that will be simply running small apps, that will be having dedicated computing, small computing. For example, if in case you have been into road transport, I have seen it in Punjab, in Rajasthan, and in the other part of Indian subcontinent. That in the state road transport, companies that we have, all of the people who are related to managing the tickets, so they will not be writing it on a receipt and then they will be giving you the ticket. They will come to your seat. They will ask where will you be going. Let's say you mention that I'll be going to, let's say Delhi. So on the device that they will be having, they will be marking Delhi. How many people? One. They'll be marking one. They will say okay. So they will be getting a receipt that will be printed. They will tear it. They will give it to you, 300 rupees. So that handheld device that is used for printing the tickets, that is used for seeing how many people have boarded the bus, how many have left off, which of the places were they going, that is based on Android. You have got smart TVs that are based on Android. You have got tablets that are based on Android. You have got smart watches. They are also using Android. So all of the mobile devices, these were the typical target audience, target devices for which Android was made. It is based on the top of Linux. It is not a Linux operating system. It is based on Linux. It has acquired a lot of features of Linux. It is inspired on Linux. It is not originally Linux, but it is based on Linux. So majorly all of those the devices that are mobile, that have limited computing, like your smartwatch, they do not require much of computing, so they will be running on Android. Android was originally made for those devices that are small, that require limited computing, and for that reason we required an operating system that can be optimized according to the usage. For example, if you have to use Android OS for smartwatch, because it is open source, you can make the necessary changes and then use it. So here, first of all, we have this Linux kernel. The hardware that we have here, this is the hardware. Like you have the shared memory, you have the audio devices, audio input, audio output, you have the display turns on, the display turns off. All of these things here of the hardware, they are managed by HAL, that is hardware abstraction layer. Here, this is the hardware, this is managed by hardware abstraction layer. This will be managed by this. As you go up, the up will be managing the below one. Hardware abstraction layer, this will be managing this one. Then using hardware abstraction layer, you can manage the audio, like when you turn up the volume. So using hardware abstraction layer, using those buttons, you are turning up and downing the volume. Similarly, when you turn on the Bluetooth, you go to the notification panel, you simply scroll down and then you turn on the Bluetooth button. So on your display, when you click on Bluetooth, in the backend, request goes to the sensor that we have to turn on the Bluetooth sensor now, and then it becomes discoverable. Similarly, when you click on the camera app, the particular camera that you have, those holes that you get to see on the back, when you click on the camera, that camera will get opened. If you have given the camera permission, it will get opened. On the top of that, we have got libraries. So the libraries are majorly C and C++ libraries, all of the actions that you want to perform. For example, you want to open a web browser. So that web browser is managed by this WebKit library. Similarly, if you want to play some video, you want to watch pictures, you want to open pictures, you want to play some videos, all of those things happen with the help of media framework. So all of the libraries that you have, that you want to execute, that you want to run, you do them with the help of these libraries. These libraries will be helping you in managing these things as well. You want to open a browser, you want to render any of the page, you can do that with the help of WebKit. Similarly, along with this, on the same level, we will be having Android runtime. When you will be executing any of the app, each of the app will be having a dedicated resource. It will be having a dedicated virtual machine where it will be executing. In the later part of today's discussion, I'll be helping you in understanding on what happens when you will be, executing any of the app. What are the various stages of the app? How does any of the app gets executed? What happens when you install it? I'll be getting to this in a bit. Above that, we have the Java API framework, wherein all of the various actions that you want to perform, like you want to retrieve the location of the user, you want to check which of the activity, which of the app is active, you want to check whether any of the SMS has been received, you want to check whether any of the phone call is to be made. All of them are being managed by Java. Above that, you have the system apps, like all of those stock apps that come pre-installed within your Android app, within your Android phone. Like you have the dialer app. You need not buy a phone and then install dialer in it. Dialer app comes pre-installed with it here. Then the email client that you have a default email client, your browser. These are some of the default system apps that come pre-installed in your Android device. With on above the stock apps, you will be having some bloatwares, you will be having some other apps that are installed by the manufacturer. There can be some of the games, like you have Subway Surf, you have Candy Crush, you have Angry Birds. These are some of the apps that will come pre-installed, but they are from the manufacturers. They are not stock apps, they are not from Android, they are coming from the manufacturers. There can be any of the reason why the manufacturer would be installing it, but they will also be coming in, but they are not system apps. System apps are those apps that will be coming in along with the stock Android OS. This is how typically an Android architecture looks like. It is important for you to know the Android architecture. You need not remember all of the names, only you should be remembering these names. That on the ground level, we have the Linux kernel. Linux kernel will be the hardware. It will be interacted with HAL, that is hardware abstraction layer. Above that, we will be having libraries, C and C++ libraries, then Java API frameworks, and then system apps. That is it. What you have inside this, you need not remember them. You need not sit and mug them up at the moment. With time, when you will be learning more, when you will be revising, you will be getting to know it. So you need not remember them now. You can go easy. No need to take that much of pressure. Just know that this is how it typically looks like in your brain. Just take a screenshot of it and you are good to go. That's it. So this is how a typical Android architecture looks like. Now the next part that we have is that we need to understand compilation. Compilation, all of you must have heard the term compilation in real life. When you have a lot of data, you compile it. You put all of the things at one place. Similarly, when you were in your school, you were in your high school, you must have done some kind of programming, may it be C, C++, Java, Python, Bash, Ruby, any of them. All of them include a process that is compilation. You must have, if in case you belong to, technical background, maybe BTech or BE or BCA or MCA, you must have had gone through one of the subjects, that is compiler design. So in that, you must have learned, you must have read that whenever we are writing any of the code, like I write print hello world. So when that compiler will be translating it, when it will be getting translated to the machine code, what are the various processes that it follows? That is compilation. When you are translating your code into its machine code so that the machine, the Android phone, the operating system can understand. That is what we call compilation, translation of the high level language to low level language to binaries, that is translation. It can be done either through interpreter or through compiler. Interpreter will be translating each of the line one by one. Compiler will be translating complete code at once. So this is how typically a Java or a Kotlin compilation work. Kotlin is quite a popular language using which Android applications are made. So first of all, we will be writing the code in Java. So let's say I have written a code. The name of the file is rohan.java. So that is .java is the extension. .java, using Java compiler, it will be converted to Java bytecode. One of the reasons that make Java so popular is because it supports cross-platform compatibility. Platform here refers to various operating systems. You can have a Java code and you can convert it to its equivalent bytecode. Once you have that bytecode, you can then run it, you can then translate it for Windows, you can then translate it for Android, you can then translate it for maybe for iOS or any of the other platform that you are interested in. You can do that. The advantage that we have for Java is it will be the intermediary code. This dot class, this Java bytecode that we have, it will be the intermediary code. After this, when it is converted to the machine language, you can convert it to the equivalent machine language of the platform on which you want to run. Like if you want to run this app on an Android device, you simply convert it to its equivalent Android code and then you run it. You want to run it on its Windows operating system, you convert this bytecode to the Windows equivalent and you run it. You will be having dedicated compilers for that. So this dot class is the Java bytecode, and this Java bytecode will then be running in JVM, that is short for Java Virtual Machine. Virtual machine, just as we have done it in the Android lab setup, that in our host machine, like this Windows is my host machine. In this, I will be running a virtual machine, that is the guest operating system, that is the guest machine. Similarly, in any of the execution of any of the Android app, currently I'm dedicating this discussion towards the Java. Whenever you are running any of the code in Java, what the computer will do, it will be assigning it some resources. Like if you have 16 GB of RAM, that JVM will be dedicated, let's say 2 GB of RAM. It will be assigning it some GPU, it will be assigning some storage, and within that Java virtual machine, within that environment, that Java code will be executing. So you will be having a .java file. Using Java compiler, it will get converted to .class, that is the Java bytecode, and then that bytecode will be running in JVM. This is how typically a Java or a Kotlin compilation works. Similar to this, you have the Android compilation, that is, you will be having a Java code. Using that Java compiler, you will be converting it to Java bytecode. You will be converting it to Java bytecode, that is .class, using a DEX compiler. Now DEX here is short for 𝗏𝗏𝗏𝗏, because here this particular Android, it will be running the code in DVM, that is 𝗏𝗏𝗏𝗏 virtual machine. Just as in Java we have Java virtual machine, similarly in Android we will be having 𝗏𝗏𝗏𝗏 virtual machine. So using this DEX compiler, this .class folder, it will get converted to .dex, that is the 𝗏𝗏𝗏𝗏 bytecode. I mentioned that you can take this bytecode and you can compile it to the equivalent OS in which you want to run. If you want to run this bytecode on Android, you will be requiring the DEX compiler, and using that Java bytecode, using that 𝗏𝗏𝗏𝗏 bytecode that will be coming in .dex format, you can run that in the 𝗏𝗏𝗏𝗏 virtual machine. This is how typically the compilation of Java or Kotlin works. This is how the compilation for Android works. When you are running any of the app, when you are writing the code and then you click on run. This is the process that happens in the background. First, the code that is written in Java using Java compiler, it will be converted to dot class, that is the Java bytecode. Because we have to run it on Android, we need to compile it using DEX, that is the DEX compiler or the 𝗲𝗏𝗶𝗶 compiler, which will then be converting this bytecode to 𝗲𝗏𝗶𝗶 bytecode. Then this 𝗲𝗏𝗶𝗶 bytecode will be running in 𝗲𝗏𝗶𝗶𝗶. Each of the app that you run, it will be having its dedicated VM here, that is DVM. You need to understand two things here. First, that is just in time, and second, that is ahead of time. What happens is when you will be installing any of the Android app, like you go to Play Store, you search for WhatsApp Messenger, you install it. Every time you will be running that app, when you click on WhatsApp, what happens in the background is this BVM file that you have, this .dex file that you have, it gets translated, it gets compiled. Now because in DVM till version 4.4, you need to keep this thing in mind, that till Android version 4.4, we used to have JIT, that is just in time approach. As the name suggests, what DVM does was, when you click on the app, like let's say you clicked on WhatsApp, WhatsApp is installed. When you click on WhatsApp, the DEX code that you have for WhatsApp, it will get translated and then the app will execute. Every time you click on WhatsApp, it will get translated and then it will execute. Every time you click, it will get translated and then it will execute. You see, why am I repeating my statements? That is because every time you click, the complete translation happens. So you can see that when any of the code will get translated, it will be requiring significant amount of resources. Whenever any of the code will get translated, it will be taking resources. Along with that, it will also be taking some time. And that is why you must have also noticed that the apps that we used to have, the Android phones that we used to have before Android 5.0, that is before Android version Lollipop, KitKat, and before that, they were quite slow. Whenever you used to click on any of the app, you had to wait. Why are you waiting? Because every time you are trying to open any of the app in the DVM, that 𝗲𝗏𝗶𝗶 bytecode, it will get translated. And because every time you open it, just in time it will get translated. Because previously, before Android 5.0 till Android 4.4, Android considered that why should we be translating the code? We should always be translating the code when the user wants it. A user wants to open WhatsApp. Okay, as soon as they will click on WhatsApp, we will be translating the code and we will be executing it. But the challenge that we have is that with the just-in-time approach, every time you will be launching any of the process, you will be launching any of the app, the code will get converted to DEX and then it will get executed. So it used to impact the performance. It made the app slow, it made the phone slow, and it impacted the user experience. And that is why in the latest versions of the Android, or after Android 4.4, that is since Android 5.0, since Android Lollipop, we are using ART. ART here is short for Android Runtime. What we do here is we will be having ahead of time. In JIT, what we used to do, every time a user will be opening the app, we will be converting the code to DEX and then we will execute. What we have done in ART is whenever the user will be installing the app, at the time of installation, we will be converting the code to DEX so that every time the user runs the app, we need not convert it. We will simply be executing it. Every time you will be having the DEX file ready, this Java bytecode ready. As soon as you click on WhatsApp, the text file will get loaded and it will be running. Previously, what was happening? Till Android 4.4, you were here. When you used to install the app, you are here. You click on WhatsApp, then the compilation happen, then this text file will be running in DVM. What we have done in Android runtime, that is from Android 5.0, is that we are here. We have the text file ready here. As soon as you install the app, we will be translating, we will be compiling, the .dex file will be ready, and as soon as you click on the app, it will be, this dex code will only have to run. You have saved this process from happening n number of times. If you are opening an app n number of times in a day, n number of times this compilation will happen. That used to happen in till Android 4.4 when we used to have JIT, that is just in time approach. Now what happens? This text file is always ready. Every time you want to open any of the app, you simply have to click on the name of the app and that text file will be running in the DVM. Why are we doing this? Because we want to save ourselves time. We want to improve the performance of the application. We want to improve the user experience. We want to save the computing resources. And that is why since Android 5, that is Lollipop, we have been following ART, that is Android runtime, that uses AOT, that is ahead of time. The codes are simple, the terms are simple, but these are very important for you to know, because when you will be taking interviews, when you will be asking your interviewee that do you understand Android OS architecture, then these types of questions, these types of conceptual questions, that if you already had DVM, why did we move to ART? If you already had JIT, why did we move to AOT? These types of questions will help you in understanding that the person who is giving the interview, do they know Android well? Do they know the inner working of Android OS? For that reason, these types of conceptual questions are important for you. After that, the next point is the IDs that we have. In Linux, you have got unique IDs. Similarly, because Android is based on Linux, in Android as well, as soon as you will be installing any of the app, each of the app will be given a unique ID, and each of the app will be running in a separate process. And all of this process as well, they will be isolated. They will be sandbox. Like here, this is the process one, or let's say Uber. This is one of them. And the second one that we have is, let's say, Swiggy. Both of these apps will be having their own dedicated processes. Like this will be process one, for example, and this will be process two. Just for the sake of example, I'm mentioning it. Now, so here, this is the app of Uber. As soon as you install this particular process, as soon as you run this app, as soon as you execute this app, this process will be given a unique ID. Typically, the IDs will be ranging somewhere between 10,000 to 9,000 to 90,999, like that here. So these are the numbers by which you will be having the UIDs. Each of the app will be having their own unique ID, and each of them will be running in a separate process depending upon what all permissions have you granted them. For example, you have given the permission to access the internet. So that will be android.permission.internet, and all of the apps that have the permission to access internet, they will be falling in a separate GID, that is group ID. For example, android.permission.internet, it is into 1033. So for that reason, all of the apps that have access to this GID means that they have access to this specific permission. For example, just for the sake of example, android internet will be having 1033, let's say. So for that reason, all of the apps that have permission to access internet, they will be having GIDs 1033. Similarly, if any of the apps has access to read the external storage, so they will be belonging to a GID. All of the apps that will be having access to the camera, they will be having a GID. GID here is short for group ID, and it is assigned on the basis of the permissions. GID is assigned on the basis of permissions, and unique ID is defined for each of the app depending upon uh, which of the process it is. Each of the app will be running in its dedicated process, and each of the process will be sandboxed. I mentioned that we have got two apps here. One is Uber, one is Swiggy. They will be sandboxed, which means that whatever is happening here, it will have no impact here. Even if in case this app crashes, even if in case this app crashes, the other apps will keep on running. This is the advantage of sandboxing. Sandboxing will be separating the app data with the code execution of the other apps. It makes Android more robust. If one of the thing fails, if one of the app fails or it crashes or it has any of the security issues, the other apps, they will not get impacted by it. This is the advantage of having sandboxes. As soon as you install any of the app, what happens is Android will be creating a folder inside /data/data and then the name of the package. You will be able to access this folder only if your Android device is rooted. Without rooting your device, you will not be able to access the Genymotion emulator that we have. In that Genymotion emulator, you will be having this accessible. In the upcoming discussions when we will be learning about ADB, I will show all of these to you. I will show you the UIDs, I will show you GIDs, I will show you this folder that see previously we did not had this. After this we install this app and now we have the folder as well. So if in case let's say you have a app by the name com.app.hacktivists. So in that case a new folder will be created /data/com.app.hacktivist like this, and then all of the files related to this folder, related to this package, related to this app, they will be contained here. Shared preferences, databases, base APK, all of them you can find them here. As soon as you install any of the app, Android will be creating a new folder here by the package name, and then all of the files related to that app, they will be mentioned here. Dedicated apps will be having their own process IDs. They will be having their own isolated sandboxes. So if in case I install a new app and I run it, it will be having its own dedicated sandbox here. Whatever I do, like com.app.activists here. So it will be having its own sandbox. Whatever I do related to this app here, it will only be in these four walls, in these boundaries. It will not go out. This is the advantage that we have of Android sandboxing. One app will not be impacting the other apps. If it is required that there is the same organization that is developing multiple apps, like we have Meta, it is having Facebook, it is having WhatsApp, and it is having Instagram. So if in case you want to share the process IDs among them, if you want to have the same user ID among all of them, like I mentioned that each of the process will be getting their own ID. So if in case you want to have multiple apps to have the same unique ID, in that case, in the Android manifest file that we will be having, that is Android manifest.xml, in that you will be able to mention that all of these should be having the same user ID, and then the multiple apps, multiple processes, they will be having the same IDs, and they can also access the data that is related to another app. Like if you want to share the data from WhatsApp to Instagram using Android manifest, you can do that. The complete analysis of Android manifest.xml is one of the things that we will be doing in the upcoming discussion. No, so this is Android app sandboxing. Just keep this thing in mind that Android app sandboxing will be helping you as an user and also as a developer to isolate the contents of your apps with the other apps that are present on the same device for the sake of security and also for the sake of stability. This is quite an important interview question. That is why I'm discussing this with you here. Along with that, one more thing that you need to know here is the zygote. When you will be booting up your Android phone, your Android device, the first process that starts up is the zygote process. It is a system service and it is used for launching apps. This is the base for all of the other processes. So what happens is when you will be launching any of the app, like let me quickly clean this up here. Here. So what happens is when you will be turning on your Android device, zygote will be turning on at first. Here, so this is the zygote. This is the base of all of the processes. When you will be turning off your Android phone during the Android initialization, zygote, that is a system service, it will get launched. Whenever you will be running any of the other app, like you click on WhatsApp. So what WhatsApp will do? WhatsApp will be forking this process. Zygote will be forking this process. You must have came across the term forking when you talk about in terms of GitHub repositories. What we do is this particular repository, like in terms of GitHub, that particular repository that we have, we will be making a local copy of it. Local copy as in I will be making a copy, an exact replica of that GitHub repository on my account. Similarly, in Zygote as well, when you will be forking it, what Zygote has got all of the core libraries that are available by the Android OS. So when you fork it, you also get access to those libraries. Like you want to use microphone, you want to use internet. So what you do is whenever you will be executing any of the app, you will be forking the Zygote process, and then all of the libraries that Zygote had, you will be able to run it. So what happens is when you turn up the phone, when you boot your phone, the Zygote, it will be launching a socket. It will be launching a socket called slash dev slash socket slash zygote. What this socket basically does is it will always be listening. What this socket will do, it will always be listening that when any of the app needs to be executed, you will be making a replica of this process, you will be forking this process, you will be assigning it the resources, and then you will be executing it. So when you run any of the app, like you have your Android phone and you click on Chrome, so what happens is Chrome as an application will be forking the Zygote service, the Zygote process, then all of the libraries, all of the permissions, all of the things that it requires that were already present in Zygote, that will get executed, that will then be running. So what happens when you turn up the Android device? Zygote will be running up. Zygote will always be listening. Zygote will be opening a socket on slash dev slash socket slash zygote. It will be listening for connections, and when it receives any of the connections, like you click on Chrome, then Chrome specific code, it will be loaded, it will be executed. I am repeating myself again and again so that by listening you can understand, you can memorize it. This is all theory, so you need to memorize it. There is no easy way to be able to memorizing it. That is why I'm making diagrams and I'm repeating my words. I'm repeating them again and again so that they are present in your subconscious mind. Whenever in the future when you will be hearing the term zygote, you will understand that Rohan said that zygote starts when Android is initialized, when the Android device boots up. It is the base process for all of the other processes. When we execute any of the app, zygote process will get forked and the app specific code that will load and execute. Zygote is important. Without zygote, you cannot execute any of the app. When any of the app gets executed, there are four stages it can be in. This is the first stage, that is the foreground process. For example, you have opened up YouTube. So when you open YouTube app, the process that you have that is active, that the user is currently using, that is the foreground process. The opposite of foreground is background. So the screen, the process that is active on the user's display, that is the foreground process that the user is using. The application that the user is using is the foreground process. The second thing that we have is the visible process. There is a significant difference between the foreground process and the visible process. That is, there is a process that the user is currently being shown on the screen, but the user is not active on that. For example, you have the, let's say, newspaper app running. It is being shown on the screen, but it has been some time that the user has interacted with that app. It usually happens that, let's say we are on WhatsApp, we are typing something, and while typing, we are thinking that what should I write next? What should I answer to this question? And by the time that happens, the screen locks. We say that the screen has timed out. How does the Android app get to know that the screen has timed out? Because it has been some time since we have interacted with that process. That process was visible on our screen, but we have made no interaction with it. We have not clicked anywhere. For that reason, that visible process that the user is not active on, that the user has not interacted with in some time, that is a visible process. Foreground process and visible process are not killed, they are not terminated, because if you are using WhatsApp while typing, if the app closes saying the battery is low, it will be negatively impacting the user experience. For that reason, what we do, what we see is that in any of the application, these are the four stages that we will be managing. First one is the foreground process. When the user is actively using the process, actively using the app, we will be calling it foreground process. Android will not kill it. Then visible process, when the app is being shown on the screen, when the app is visible on screen, but the user may not be active on it, then also we will not be terminating it, we will not be killing it. The third thing that we have is the service process. These are the processes that are usually running in the background. For example, you have a video that is being played on YouTube. You have got YouTube Premium. You are playing a video, you lock your phone, and it is running in the background. It is not being shown to you on the screen. It is not visible. It is not in the foreground. The phone is locked. But in the background, that app is running. That process is running. So that is the third stage. We call it the service process. The third stage is when any of the background process is happening, like on your browser, you're downloading something, or using Play Store, you're downloading something. Let's say you are downloading a game. A game is of 1.2 GB. So you click on install, you lock the phone, and you put it aside. So when you lock the phone, it goes into the background. In the background, the network tasks will happen. Downloading will continue. Once the download completes, the installation will happen. And when the installation completes, okay. So that is the third one, when the app, the process is running in background. And the fourth one that we have is the cache process, which means the process that is running in the background on specific events. For example, you have a process that is responsible for fetching the new emails after every 5 minutes, let's say. So if in case the battery is low, or if in case the internet is not there, or any of the issues there on any of the specific trigger, that particular process that can be terminated, that can be killed. That is a cached process. Some people call it cache, but the current pronunciation is cache. Just as you pronounce CASH, similarly you pronounce CACHE, cache. So all of the cache process that you have, you can kill them. The Android can kill them to save the computing resources for the sake of survival. For example, you must have noticed that when your phone's battery is low, even if in case you get a new mail, you do not get the push notifications. But as soon as you plug your phone back to the charging, you will see that you have received an email. Why does that happen? Because Android OS knows that the battery is low, and now if in case we do not kill those processes that are not mandatory, or that are just running in the background, the phone's battery might end. So for the sake of survival, so as to elongate the battery life, so as to elongate how much time the phone will be turned on, these types of cache processes, they will get terminated. So these are the four life cycles. This is the complete life cycle. First is the foreground, that is stage one, when the app is running in the foreground and it is being actively used by the user. Second, that is stage 2, visible process, when the app is being shown on the screen but it is not active. Third, that is stage 3, the service process, when the particular app is running in the background. And the fourth, that is the cache process, that is stage 4, when the system can kill that particular process, can kill that app to save the resources, to save the battery, to save CPU, to save GPU, any of the resources when Android OS wants to manage, when it wants to save, it will be having the option of terminating the cache processes. So this is how it works. This is how Android OS works. I can understand its theory. It is not possible for all of you to understand a lot of things, to remember a lot of things at once. For that reason, I have filtered out the resources, that how does the Android compilation process happens. Here in this article, you will be able to read it. Then why did we move away from DVM and we switch to ART? Here you will be able to find. Here you will be able to find the difference between both of them. I was going through both of them. I found them well good, so I'm sharing both of them with you. And then fourth, the processes that we have discussed, stage 1, stage 2, stage 3, stage 4. Here you will be able to find more on them. I would suggest that you do not go deeper into them at the moment, because the things that you require to know to do Android security testing has already been said by me. If you read this article, you will find a lot of other things as well, like service, service.start foreground, start service, set foreground. Please do not read about them now. You will end up confusing yourself. I will be sharing this resource with you for your future reference. When the training has reached to a certain amount of advanced level, that yes, now you will be able to understand this is what it means. Now you are quite well versed with Android OS. Then these resources will be helping you. If you read this resource now, you will get confused. I am sharing this with you now because the resource, the content that I am speaking, I have learnt it from here. I will always prefer that you go through the official resources like developer.android.com. This is the official documentation for Android. I will always prefer, I will suggest as well that whenever you have to read regarding any of the product, regarding any technology, always only refer to the official documentation. So it will be containing a lot of deep insights as well, lot of technological terms. I will suggest do not go through them now. You will be you know confused. If you read a lot, you will get confused. So for now, do not read this. I'll be sharing this link with you though for your future reference. But still, do not read these hyperlinks. I will strongly recommend you not to read them now. I will let you know when you can read it. Now, all of these things that are mentioned here, gradually I will be discussing it with you, both the theory and the practical. What is a service? What is an activity? What is a broadcast receiver? Now, when will they be killed? What is broadcast receiver dot on receive? We will be learning them. We will be doing the source code analysis of Android apps. So when we will be requiring anything, I will be covering it with you. So this is all that you needed to know related to Android OS. Today's discussion was important for all of us because we have to give interviews, we have to take interviews, and if you do not know how anything works, how will you be able to pen test it? So today we have discussed about Android OS architecture, about Android permission models, about processes in Android. In the upcoming discussion, we will be discussing on ADB. We will be getting to the practicals. Using your terminal, how can you control any of the Android mobile, any of the Android device? Controlling as in you can install any of the app, you can delete any of, you can uninstall any of the app, you can copy files from your local computer to the Android device and vice versa. If you haven't set up your Android lab till now, please do that. I believe I have already shared the link to the YouTube video using which you can set it up. If not, I will again reshare it in the group, in the WhatsApp group. Please set up your lab before the next discussion. Tomorrow we will have a look on the practicals. We will be managing our Android device using ADB, that is Android Debug Bridge. How do you set this up? If you have a physical rooted Android device, how do you make a connection between ADB? How does ADB work? The client server architecture. What are the various commands we have in there? All of the things we will be discussing, both theory and practical. Please make sure your attendance in tomorrow's discussion. ADB will be used in all of the upcoming sessions. No matter which security issue with we are learning, ADB will be required in that. We will be requiring ADB. So please make sure that you attend tomorrow's session. Now, if you have any questions or queries, we can discuss them. Okay, it looks like Vikash and Arun have already marked their attendance. Everyone else, please mark your attendance in the chat box. If you have any questions or queries, we can discuss them now. I'll be the last one to leave the room. If you have any questions, we can discuss. Otherwise, please mark your attendance in the chat box. I'll share it with the management team. And once that is done, if you have no unresolved queries, you may leave the discussion for now. I'll see you tomorrow. Have a very good night.